Good morning, everyone. Friends of Lambda Island, fans of Clojure, or just curious people looking to see how other people approach these puzzles. It's day 3 and we're still here. Day 1 and 2 were pretty easy. We'll see how fast they make it harder. But I got some tea and let's see what we have. Day 3, toboggan trajectory. So I learned yesterday that apparently the stress is on the second syllable, and this is indeed a sled. So now that we have the toboggan login, problems resolved. We set off towards the airport. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area only grow on exact integer coordinates in a grid. That's convenient. You make a map, which is your puzzle input, of the open squares and trees. You can see, I can see this is already going to be more interesting. These aren't the only trees though, due to something you read about ones involving arboreal genetics and biome stability. The same pattern repeats to the right many times. I see. Okay, so it's just sort of looping. You start on the open square in the top left corner and need to reach the bottom. Okay, so I start here, below the bottommost row on your map. The toboggan can only follow a few specific slopes. You opted for a cheaper model that prefers rational numbers. Start by counting all the trees you would encounter for the slope right 3, down 1. So from your starting position at the top left, check the position that's right 3 and down 1. So I guess it's 1, 2, 3, down 1. That would be here, right? Check the position that is right 3 and down 1. Then check the position that is right 3 and down 1 from there, and so on until you go past the bottom of the map. The locations you check in the above example are marked here with O, where there was an open square, and X, where there was a tree. In this example, traversing a map using the slope would cause you to encounter 7 trees. Okay, so we just need to count the trees that we run into. Starting at the top. It's interesting the map using this slope has to encounter 7 trees. Right, so it only repeats to the right, yeah. How many trees would you encounter? Okay. To begin with, get the puzzle input. Actually, oh, and mistake I always make. Let me maybe show you again because I wasn't showing you. So we get this. So this is a map of trees. Oh yeah, hey Alexander. So I tried something new today and tried embedding the YouTube chat in the video, and it seems like it's working fairly well, so that's cool. Yeah, so this is our map. These are empty spots, these are trees. We start here, we do this particular pattern, kind of like a horse in chess, sort of, you know, but except it's 3 to the right and 1 down. And so this map repeats endlessly to the right. And so we need to follow that pattern. Jump, 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 jump. You see that here. So 3 to the left, 1 down, 2 to the left, 1 down. 2 to the right, sorry, 1 down, 2 to the right, 1 down. And then count how many times we encounter a tree. And as I said, we need to start with grabbing the puzzle input. So this is my Advent of Code project. As mentioned, this is all on GitHub. You can find it under Lambda Island AOC 2020. And there was some chat yesterday on Clojure in Slack if it was possible to fetch this, sort of automate fetching the puzzle input. And that is indeed, I mean, it's a little bit of a hack. Basically, I just sort of used my browser tools to find the current session ID, the current session cookie, and then stick that into curl, and then we can fetch that. So that should mean that now under resources, puzzle input 3, we have our map. Ooh, and this is so this is already a sizable thing. Yeah. But yeah, let's start with the demo input, see if we come to 7. All right, so off we go. Puzzle03.clj. Still need to check in here. Right. Yeah, so first we need to parse this, right? Yeah, someone asked me yesterday why I wasn't using Regal. So Regal is a library that we created for creating regular expressions using sort of this Clojure hiccup syntax. But for what we were doing yesterday, I really don't think Regal is the right fit. Like, I really created Regal because I had some cases where I was really building up very complex regular expressions and also needed generators for those expressions. And that's where Regal really shines, because you sort of get, you get the generators, you can, parse and go back and all these kind of things. If it's really just a straightforward one-liner, I think a regular expression, I mean, the one we wrote yesterday is still very readable. Okay, so demo input. I mean, basically, let's just say that we split this by new lines, and then I'm gonna use vectors for everything so that we can easily look up stuff by index. So I'm gonna map over these rows. And then just sort of say, okay, so this is a row, and then I'm going to do the same thing here, map v row, and in this case, actually, I guess I can just do this. So, like, if it's a tree, then I'm just going to say it's true, and if it's a free spot, then I'm going to say it's false. So I'm kind of making use of the fact that map is a function here. Yeah. Looks good, huh? Now, yeah. So let's call that my map, so we don't overwrite the map function. And then I kind of want a helper function. Like this, which just sort of looks up a specific coordinate. Now for that, because it repeats endlessly to the right, so let's say that our coordinates start on the top left, right, and x goes that way and y goes down. And so for the x value, I first need to know what the width of the thing is, which is the count of the first, I guess I need to pass in a map here, count of the first row of the map, and then I can just say get in this map. Now here I need to turn it around, right, because it's first y, so because we first nest rows, and then modulo, right? Number divider x width. Good, so now we should be able to say tree my map, so is 0, 0 a tree? No, but it's 2, 0, 3, yes. 3 also, but 4 not. And then how, why is this thing at the moment? My map 11 wide, so that means position 11 should still be false and 12, no, 12 should be true. So it's 11 wide. That should mean that if I'm at number 12, that's here, 13, 14, 15. Ah, yeah, okay. So 12 still false, 13 is still, no. Oh no, yeah. 0 indexed. It's 11 wide, which means that this is 11, which is this, so 11, 12 false, 13, 14, yeah. So that works. That also means that if we go below the map, so now let's try going down, let's say if we go 2 down, 0, 1, 2, and then the first X, this should be true. Now if we go all the way down, we start getting nils, and I guess that way we can check that we're off the map. Yeah, and maybe now the easiest is just sort of a loop recur. Yeah, because we really just want to iteratively. I mean, yeah, I guess I could do something with iterate. So let's say, no, yeah, okay, let's try to do this nicely functional. So if we encode, we kind of keep track of our current position. So let's say, and I'm just going to continue to use vectors here. You don't want to have too much positional stuff and sort of have to remember that like position 0 is this, but in this case, we have 2 or 3 things. So if I say that our current position is, my map 0, 0, and then, well, 0, 0, yeah, so our current position is my map, we're at 0, 0, and we've encountered 0 trees. And then, when we sled down, so let's destructure this here, we're at X, at Y, and these are the amount of trees that we've gotten. X plus X 3, right? And then Y plus Y 3. Tree, my map XY. And then we do a cond here, because we sort of have this now. Yeah, true, false, nils. Not always great to do this internally logic this way. Don't do this in your real code, folks. If you need to encode 3 different things, then don't just true, false, nil. But I'm gonna roll with it. So if tree is nil, then we're done. And I'm just gonna return. How do we signal that we're done? Shall we do something like done trees? Or maybe reduced trees. This is kind of a wrapper which reduce also use, which you can sort of use to signal early exit from a reduce or a transduce basically. So if it's true tree, then our new state is my map xy inc trees, increment trees, and else it has to be false. Then our new state is just this. Okay, and so now we can sort of start sledding down. So we have pause, and then we sled once. Let's look at see what we get. Oh, what? What's happening here? Oh, 3-3-0. Why is 3's... Wait, did my pass wrong? Lost pass. 0. Trees. We're at 3. +1, by the way. So we're at 3-1. That's correct. Why is trees nil? Good old print line debugging. Trees nil on the input. Oh, because what is pos? Oh no, we don't have the trees in there yet. Oh, because it's my pos? No. Pos. Four. Okay. Okay, that looks better. Okay, so if we select a couple times now, we're at 6, we've encountered one tree, we've encountered another tree, no, we have not, no, now we've encountered another tree, and so forth, right? And eventually, after a couple more iterations, yeah, value 7. Okay, so now we just need to say iterate position sled. So now we sort of get an infinite sequence of different states that we're in. And then I'm just gonna drop while complement reduced. So drop everything until we find a reduced, and then we you just deref a reduced to get it, right? Reduce 10, yes, you just deref it. So we take the first of this should be our reduced, and then we deref that. Key must be integer. Where's this happening? Drop while. Persistent vector. What am I doing wrong? Let's try using bits. Wait, iterate takes the function first. That's the problem. All right, 7. So now on the real input, let's pull this out. Input to map. Input. Demo input 0, 0, 0. Evaluate it, yes. Okay, now let's see IO resource. Resource at .io, right? So the resource is puzzle input 03.text. Yeah. In this case, I'm not going to use line seek, I'm just going to slurp it because we already have a function that deals with strings. So now I can turn this into a map. And I can basically do the same thing. Well, let's also pull this into a function defn sled down input. So sled down demo input is 7. And now the question is going to be if this is fast enough. Oh yeah, so far so good. 164. Four concurrent viewers. Do say hi in the chat, folks. All right, part 2. Time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop after all. Determine the number of trees you would encounter if, for each of the following slopes, you start at the top left corner and traverse the map all the way to the bottom. Okay, so yeah, like, get a different chess move, basically. Or different chess moves. What do you get if you multiply together the number of trees encountered on each of the listed slopes? Well then. So yeah, for our demo input, we should get 336. Let's start by encoding this. Let's see, do I know enough Vimy magic? Can I do digit? No, no, 09. Alright. Emacs regular expression, man. There you go. Okay, so I'm gonna change my sled function to first take this slope. So down x, down y, and I'm putting that slope argument first so that I can partial it. So in this case, this would have been partial. Well, actually, yeah. Well, let's see. We also get a slope here, and then I say partial sled slope. So sled down 3 1 3 1 3 1. Oh, something's happening. Ooh, I left a print line in there, and also we seem to have an infinite loop somewhere. Can I interrupt this? Let me just restart my REPL if it will do that. Okay, nuclear option. Yes, it's this one. No, maybe it wasn't that one. Closed, okay. Yeah, sure, cider. Okay, let's take this from the top. Yeah, don't do that. That's really going to slow things down. Down Oh. You can see that it's 7:30 in the morning and I have not had an adequate amount of tea. Speaking of which. Okay, so now this works, yes. And so same here for my puzzle input, yes. And so now let's try this for the demo input. So basically what we want to do is for S slopes, sled down, slope, demo input. In this case, we're reparsing this every time, but I think it'll be fine. We needed to multiply these, right? S and slopes, yes. Slopes. 336, that's exactly what we were expecting. And if I do this for the real input, let's put this output. Alright, we have a number. Is a D number. Alright. What kind of tea am I drinking? I'm drinking a black tea that I got around the corner here in Berlin. Forgot the name. I can tell you on the stream tomorrow. It's nothing fancy, but it does the job in the morning. I'm quite partial usually to Taiwanese oolongs, but lately I've been drinking more just like plain black teas in the morning. All right, so this is what we have. I think it's not bad. I mean, still no big performance issues. How long is this taking? No, come on. 8 milliseconds. Yeah, okay. I mean, I'm sure you can get this a lot faster. I mean, and we're wasting time just reparsing this input for starters. But I think this is reasonable. So I'm gonna cut it there, but I hope to see you folks tomorrow. I'll also be sending out a newsletter to Lambda Island members and subscribers. So if you have a Lambda Island account, even if you're not currently a subscriber, you should get that pointing folks out that I'm doing these videos, but also sharing a private leaderboard so that all you friends of Lambda Island can get on this leaderboard with us together. We can kind of see how the rest is doing. So hope to see some folks on there tomorrow. That's it for today. Thanks for watching.